So, verifying trig identities. When we try to verify something, we say that it's true. So, for example, let's take an example from algebra where we have this expression and this expression, and we're trying to show that they're equal to each other. In order to do that, we need both sides to look identical. So that's your goal when you're verifying trig identities, is to make both sides look identical. So, for example, 2 times the quantity of a plus b plus 2a is equal to 6a plus 2b. And I put the question mark there is because we haven't verified it. Now, we can do this lots of different ways. We could factor this one out over here, we could change this one around over here, and see if we can get two things that are equal as long as we continue doing what we're supposed to do mathematically. So here I just added like terms, which is a fine thing to do mathematically, and I left this side alone. Then I went ahead and distributed here my 2. I could have equally factored out a 2 right here, and I would end up with both things on the same side, but instead I chose to distribute. So I have 6a plus 2b is equal to 6a plus 2b. I verified my identity by making the sides identical to each other using my math reasoning. So for example, we'll do it with trig now. I have tangent squared of x times cosine squared of x is equal to 1 minus cosine squared of x. So I want to verify that this is true, which means one of these sides, or both of those sides, have to look identical. So I'm going to take this side over here, and what I'm going to do is substitute in for tangent squared of x, the identity I know, where I know tangent of x is equal to sine x over cosine of x. So tangent squared of x is equal to sine squared of x over cosine squared of x times cosine of x, and I also changed this side. So 1 minus cosine squared of x is equal to sine squared of x, and that's from the Pythagorean identity, where we have sine squared of x plus cosine of squared of x equals 1. And then just solving for sine squared of x, in this Pythagorean identity, I subtract a cosine squared of x from both sides, and I get that sine squared of x is equal to 1 minus cosine squared of x. So instead of 1 minus cosine squared of x, I can substitute in sine squared of x. Then I can go ahead and make a 1 here. I have cosine squared of x over cosine squared of x, which is just 1. And then I have sine squared of x is equal to sine squared of x. Both sides are identical. Sometimes you'll just leave one of the sides the same all the way down and only change one of the sides. But you can change either side. And there are multiple ways you can solve for these. So let's look at another one. I have 1 minus 2 times cosine squared of beta over sine of beta times cosine of beta is equal to, and we'll go ahead and put our question marks here, is equal to tangent of beta minus cotangent of beta. Now, you will find a couple of techniques that help you reason through mathematically how they're equal to each other. One of the ways I use is to rewrite my tangent and cotangents as sine and cosine. Now, that doesn't always work well, especially if you're dealing with like a tangent identity that you can try and maneuver, but sometimes that's very helpful. So that's what I did in this case. And oftentimes you'll have to try a couple of times to see what's easiest. Sometimes it will take a whole page to do a problem, and sometimes if you notice something or get lucky basically on your guess, it will take you a much shorter time. So here, I didn't change the left-hand side at all, but I rewrote tangent as sine over cosine and cotangent as cosine beta over sine beta. So just rewrote those. Another method that I use is to find a common denominator. So finding a common denominator between these two that I'm subtracting, it's just sine b times cosine b. So I'm going to multiply this fraction by sine b over sine b, my special one there, minus this fraction by cosine b over cosine b. And so now I have a common denominator where I have sine beta, b, I said b, but beta, sine beta times cosine beta. I didn't change the left-hand side at all. I don't really know what to do with that yet. I could change it. I could put this over the denominator minus this over the denominator, but I chose to leave it just as it is. Now I have a common denominator. I'm going to go ahead and multiply those to get sine squared, multiply those to get cosine squared. So I have sine squared minus cosine squared over sine beta cosine beta. Now that works out really well. I can see that I'm getting closer. So my denominator is the same. My numerator, however, is not. This one's got 2 cosine squared beta, and this has both sine squared and cosine squared beta. So if I can rewrite sine squared beta in terms of cosine squared beta, I think I might get over there. So that's my thinking process there. So I'm going to take the Pythagorean identity, sine squared beta plus cosine squared beta equals 1, and I'm going to solve for sine squared. So sine squared beta, I'm going to go ahead and subtract cosine squared beta from both sides, and I get 1 minus cosine squared beta. I'm going to take that 1 minus cosine squared beta, and I'm going to substitute it in for sine squared beta. It's the same thing. So I'm substituting this in for my sine squared beta. And now I have 1 minus cosine squared beta minus another cosine squared beta all over sine beta times cosine beta. This, when I'm adding like terms, I'm going to get 1 minus 2 cosine squared betas. So let's take a look at that. And now I have both sides equal to each other. And notice I didn't change my left-hand side at all. I went through the process, didn't change my left-hand side, and just manipulated my right-hand side mathematically. And sometimes you can do both of them, sometimes just one, and there are multiple ways to do it. Some things that kind of help me as I go through trying to verify identities is writing in terms of sine and cosine. If all else fails, you can always do that. Sometimes it's a longer method, but writing in terms of sine and cosine. You also have to be pretty good with your fractions, and especially complex fractions where you have fractions over fractions. So think of them in terms of a division problem. Getting a common denominator often helps if you have addition or subtraction of fractions. Sometimes factoring will help you. For example, if one of your terms or sides is 1 minus cosine squared, you can factor that to 1 plus cosine squared and 1 minus cosine squared. That's a difference of squares. So when we did that, we would let u equal cosine of x, and so this would be like 1 minus u squared. So 1 plus u, 1 minus u. So just going back to our factoring and using our trig while we factor. Sometimes multiplying by a conjugate and using a special 1. So for example, if we had sine of alpha over 1 minus cosine of alpha, it will help to just multiply by a 1 and won't change the value. And it could help us figure out how to simplify it a little bit better. So 1 plus cosine of alpha, 1 plus cosine of alpha, because when we multiply this, notice that this multiplies together to give me 1 minus cosine squared of x right here. So when these multiply together, it will give me 1 minus cosine squared of alpha. You still have this 1 plus cosine of alpha in the numerator though. It doesn't just go away. You have to multiply by a 1. So these are some of the techniques that help me get through these identities, and sometimes you'll have to play with them for a little while and you'll have to do a lot of erasing. So just be ready, try to use your math knowledge and your reasoning.